this episode, we focus on a deceptively simple challenge that shows up constantly in operations automation, taking messy or semi-structured text output and turning it into clean, predictable input for the next step. Many systems produce output that is technically structured but not formally packaged as a structured format, meaning the information is in columns, fields, or repeating patterns, but it still looks like text. If you feed that raw output directly into downstream automation, you create a fragile pipeline where small formatting differences can break parsing or, worse, change meaning without obvious errors. The concept behind awk is that it lets you treat each line of text like a record and each piece of that line like a field, so you can extract, transform, and reformat data in a controlled way. For this certification, the goal is not to memorize syntax, but to understand how field-based transformation reduces operational risk by making inputs consistent. When you learn to think about selecting the right fields, normalizing separators, and producing stable output, you gain a reliability skill that keeps automation predictable across environments. Predictability matters in cloud and security contexts because many actions depend on accurate identifiers, correct status values, and consistent signals, and awk-style transformation is often the difference between reliable pipelines and pipelines that fail silently. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. A helpful starting point is to recognize why semi-structured output is so common, even in modern systems. Tools often print tables because tables are easy for humans to scan, and logs often include repeated key fragments because they are easy for humans to read. That human-friendly formatting, however, can be unfriendly to automation because humans can ignore extra spaces, align columns visually, and infer meaning from context, while scripts need explicit boundaries. In cloud operations, you may encounter output where the first column is a resource name, the second column is a status, and the rest is descriptive text, and the automation step that follows might only care about the name and status. If you do not transform that output into a clean form, you risk passing extra text into a process that expects only an identifier, which can lead to wrong targets or failed lookups. The operator mindset is to treat human-friendly formatting as a presentation layer, not as a reliable data interface. Awk represents a structured way to strip away the presentation layer and keep only the fields that carry meaning for automation. Once you adopt this mindset, you stop trusting raw text and start producing stable inputs deliberately. Field thinking is the core mental model here, because awk-style transformation is built on the idea that a line can be split into fields using a separator. A separator might be whitespace, a comma, a colon, or another delimiter, and the choice of separator determines what counts as a field. Beginners often assume whitespace splitting is always safe, but that can be risky when fields contain embedded spaces, such as names with spaces or descriptive text. That risk shows up as shifted field positions, where the value you think is field 2 is actually field 3 in some lines, causing misextraction and inconsistent output. Safe transformation begins with identifying the true boundary markers in the output, meaning the characters or patterns that reliably separate meaningful fields. Sometimes that is a consistent delimiter, and sometimes it is a fixed format pattern that can be recognized. Once you pick a reliable separator, field extraction becomes stable, and stability is what keeps pipelines predictable. On exam questions, you can often spot the safer approach by choosing the method that uses a clear delimiter rather than relying on visually aligned spacing. Selection is the next key concept, because you rarely need every field, and carrying unnecessary fields forward increases both noise and risk. If your downstream logic only needs a resource identifier and a status value, selecting only those fields reduces the chance that unexpected text will be interpreted as part of the identifier. It also improves performance and clarity, because smaller outputs are easier to validate and easier to troubleshoot. Selection is also a safety practice because it supports least exposure, meaning you do not pass sensitive or irrelevant values through the pipeline when they are not needed. In cloud environments, output might include internal metadata, host names, or identifiers that are sensitive, and unnecessarily carrying that forward can increase the chance of accidental logging or leakage. A disciplined approach selects the minimum fields necessary for the next decision or action. This is not about hiding information. It is about controlling information flow, which is a core operations skill. When you think in terms of selection, AutoOps becomes a tool for enforcing clean boundaries between pipeline stages. Normalization is where transformation moves from extraction to creating predictable inputs that downstream steps can depend on. Normalization means making the output consistent in format, such as ensuring that fields are separated by a single delimiter, that trailing spaces are removed, and that values are in a standard case or representation. The goal is to reduce variability, because variability is what breaks automation across environments and over time. For example, one environment might label a status as running while another labels it as running, and if your downstream logic does an exact match, it could behave differently. Normalization can address this by converting to a consistent case before comparison, which turns a formatting difference into a non-issue. Another normalization example is making sure numeric values are consistently represented, such as removing commas or converting units into a standard form. In security-focused automation, normalization is especially important when you are comparing outputs to expected values, because even small differences can trigger false alarms or misdetections. AutoOps-style thinking encourages you to treat text as data that must be shaped into a stable contract. A common beginner mistake is to treat transformation as purely cosmetic, like reformatting for readability, rather than as a way to enforce meaning. In operational automation, formatting choices can change how a value is interpreted, which means transformation is a semantic activity, not just an aesthetic one. If you output fields without clear separators, downstream steps might merge values accidentally. If you include labels alongside values, downstream parsing might break or capture labels as part of the value. If you preserve variable amounts of whitespace, downstream matching might become brittle. A safe transformation strategy produces output that is deliberately machine-friendly, such as one value per line, stable delimiters, and no extra decoration. This is the same principle you saw with regular expressions and grep filtering, where the point is to extract a clean signal rather than to preserve the full noisy context. The exam often rewards answers that reflect this machine-friendly mindset because it aligns with how pipelines stay reliable. When you separate human presentation from machine interface, you reduce the chance of misinterpretation. AutoOps also encourages you to think about record-level logic, meaning decisions and transformations that happen per line. Record-level logic matters because not every line in a stream is necessarily the same kind of line, especially in outputs that include headers, separators, or summary lines. Beginners often forget to handle non-data lines, leading to transformations that accidentally include headers as if they were real records. That can cause downstream automation to attempt actions on the word name or status or other header labels, which can look like a weird error until you realize what happened. A safe approach includes recognizing and excluding non-data lines, ensuring that only valid records are transformed and passed forward. This is a reliability pattern. Filter out the parts that are not true records, then transform what remains. Record-level thinking also helps you handle lines that are incomplete or malformed, because a robust pipeline should detect and skip or stop when data is not in the expected shape. In cloud security operations, malformed lines might indicate errors upstream, and ignoring them can hide failures. Safe automation treats malformed records as signals, not as noise. Another important concept is defensive parsing, which means you do not assume every line will have the expected number of fields. In real environments, occasional lines can be missing fields due to partial errors, different formatting, or unexpected messages mixed into the stream. If your transformation logic blindly extracts a field that does not exist, the output might become empty or shifted, and that can cause downstream steps to behave unpredictably. Defensive parsing includes checking that fields are present and valid before emitting them. This connects to fail-safe design because if the input is not trustworthy, the safest behavior is usually to stop or to refuse to produce output that might be misused. In some contexts, skipping a bad record might be acceptable, but only if skipping does not hide a broader failure or cause partial actions that create drift. The key is to choose behavior intentionally rather than accidentally. Exam questions that involve parsing often test whether you will validate structure before acting, and defensive parsing is a direct expression of that principle. It is not about being pessimistic. It is about being responsible with the data that drives actions. Because awk-style transformation often sits between stages, you also need to consider how downstream consumers interpret the output you produce. If the next stage expects one identifier per line, your output should match that contract exactly. If the next stage expects key-value pairs, your output should use a consistent delimiter and should avoid extra spaces that could be misread. If the next stage expects numeric values, your output should ensure that those values can be parsed as numbers, not as decorated strings. This contract thinking is crucial for preventing pipeline breakage, and it is also crucial for preventing silent failures where the next stage reads something but interprets it incorrectly. In cloud pipelines, a small contract mismatch can cause an entire stage to act on the wrong set of resources or to skip necessary actions, and those problems are often discovered late. A safer design includes validation at boundaries, meaning you check that the transformed output matches the expected shape before passing it forward. Even without implementation details, you should recognize that transformation is a boundary control, and boundary controls are where you protect automation from upstream variability. When you treat output shape as a contract, your pipelines become more dependable. Awk is also valuable for creating consistent reporting outputs that support observability, which is the ability to understand what automation did. If you extract the key fields from a stream, you can create a concise summary of what happened, such as listing the targets processed and their resulting statuses. That summary is easier to review and easier to archive than raw output, which can be noisy and inconsistent. In security and cloud operations, clear summaries help you validate that automation covered all expected targets and did not accidentally include unexpected ones. Summaries can also help you detect anomalies, such as one target with a different status, without scanning hundreds of lines. The risk is that summaries can hide context, so you still need access to raw output for deep troubleshooting, but summaries are excellent for routine verification and for quick detection of surprises. This is similar to the earlier concept of filtering with grep, but awk-style transformation goes further by shaping the output rather than simply selecting lines. When you can shape output cleanly, you can build automation that is both efficient and auditable. Efficient and auditable is the sweet spot in operational design. Another beginner misunderstanding is thinking that awk-style transformation replaces the need for structured formats like JSON, when in reality, it often complements them. In many workflows, you will encounter both structured formats and semi-structured text, and you need to handle each appropriately. Awk is especially useful when output is table-like or field-like, but not truly structured as a nested object with explicit types. It can also be useful for quick reshaping when you need a small piece of information in a predictable form. The risk is using text transformation where structured parsing would be safer, such as when you have true structured data available, but you choose to treat it as raw text because it is easier. That choice can lose type information and create silent failures when values are interpreted incorrectly. A confident approach is to choose the right level of structure for the task. Use structured parsing when you have structured data, and use field-based text transformation when you have reliable field boundaries, but not a full schema. This judgment is exactly the kind of operational thinking the exam is trying to measure. The goal is not to worship one tool, but to choose methods that preserve meaning and reduce ambiguity. As you connect this topic to the broader automation themes, you can see how it reinforces safe design across domains. Primitive types matter because field extraction and normalization often produce values that must be interpreted correctly, especially when numbers and booleans are involved. Conditionals matter because you must decide what to do when a record is malformed or a field is missing, and fail-safe behavior should guide those decisions. Iteration matters because transformation is often applied repeatedly across many lines, and safe iteration prevents drift and ensures consistent output. Parameters matter because different environments may have slightly different output formats, and a reusable design makes those differences explicit rather than hidden. Functions matter because transformation logic should be encapsulated so it is consistent and maintainable rather than copied in fragments. Logs matter because the transformed output often becomes part of your validation story, helping you confirm that automation did what it was supposed to do. When you see AuC as a way to enforce contracts between stages, it becomes a reliability tool, not just a text trick. The main takeaway is that AuC-style transformation is about turning semi-structured text into clean, predictable automation inputs by thinking in terms of records, fields, selection, and normalization. When you identify reliable delimiters, extract only what is needed, handle headers and malformed lines safely, and produce output that matches a clear contract, you reduce a major source of pipeline fragility. That reduction matters in cloud operations and security contexts because automation often acts at scale, and scale amplifies the cost of misparsing. On exam day, the best answers in this area usually reflect a preference for stable field extraction, explicit normalization, and defensive handling of unexpected input, rather than brittle assumptions about formatting. In real environments, those same habits reduce incidents and reduce the time you spend debugging problems caused by subtle output changes. If you can consistently shape text into predictable inputs, you can build pipelines that stay reliable even when upstream systems change their formatting slightly. That is confidence in action, not hope that the text will behave, but a deliberate design that makes it behave.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.